Hi Year 10, going through your paper 2 for the triple awards. Again, make sure your name's on it. I'm Mr. K. So, first question. Make sure you're underlining chemical names. So potassium sulfide is an ionic compound, and we've got potassium sulfide there again. And you had to complete the table to show the electronic configuration. So this was the arrangement of an atom, and this is the arrangement of an ion. So if we look at them, these are the atoms over here. So looking at our potassium first, this electron, okay, is going to be removed, this outer one, and it shows you that there that we've lost this one electron here, okay. Now this one electron then goes to sulfur, and sulfur, like oxygen, it has 1, 2, 3, 4, 5, 6 electrons in its outer shell, and it's going to gain one, okay, but it's also going to gain another because we've got these two unpaired electrons here, okay. And so now sulfur has 8 in its outer shell. So it goes from 6 to 8 because obviously it's trying to complete its outer shell. That's worth 1 mark just for that electronic configuration of 2, 8, 8, 8. Then you needed the charges. Well, as we've already established, potassium is going to lose this 1 electron, and sulfur is going to gain 2. So potassium will be at +1 because electrons are negative. So if you lose them, you become positive. And sulfur is gaining that negative electron, so it becomes 2 negative because it's gained 2. Question B, explain why potassium sulfide conducts electricity when molten. And it's quite simply, ions are free to move, or ions move towards the electrode. Okay, I'm just going to change all text here to red to make it a little bit more obvious. So yeah, the ions are free to move, and the mark scheme would also allow ions are mobile as well, as you can see here. Okay, moving on. Explain why potassium sulfide has a high melting point. So quite a few marks worth for this. This is a 3-mark question, and I'm going to give you a model answer as well. So, firstly, your mark 1 is looking for electrostatic forces between ions. Okay, so my model answer would be something like the electrostatic forces between ions are strong, so they require lots of energy to overcome, and that'll be your 3 marks there. If you remember from the paper 1, this stock statement that I've told you before, mark 3 for this stock statement, so they require lots of energy to overcome. Yeah, you've used something similar before. Always add that when it's talking about a high melting or boiling point and why. Yeah, add that final statement to say, therefore it requires lots of energy, so you're showing the examiner you fully understand. Mark 2 depends on the mentioning of mark 1. And if you had started to talk about covalent bonds or intermolecular forces, you wouldn't get mark 1. Remember, intermolecular forces are only with simple covalent. Okay? An ionic lattice has loads of ionic bonds. There aren't molecules. Okay, question 2. Why does the gas decrease during heating? So this is thermal decomposition. Okay, of copper carbonate, and we're producing a gas here, so you should see that, and that gas is going to escape, and that's what you had to put for your answer here. They accepted quite a few: gas given off, allow carbon dioxide, gas evolved, gas released, so quite a few answers there. The name of the gas didn't matter either. State the colours of the solids in the reaction. Well, copper carbonate, you've seen it before, is green. Copper oxide is black. Both of these worth 2 marks. In which experiment might the decomposition not have been completed? okay, not been completed, and it's experiment 1. And the reason for that is, if you have a look at your table up here, experiment 1, the masses after 6 minutes are still going down. Okay, so 2, 4 and 6, none of those are the same. If you look at all of the other experiments, this is the same as this is the same as this, and this is the same as this. That's telling you that the mass is staying the same, and therefore reaction has ended. Okay, but this one is still changing, so it's still going on. So we're looking at experiment 1. Give your reason for your choice. Well, the last 2 masses are not the same, or no 2 masses are the same. Okay, and there's a few things. Mass is still changing, except results instead of with the word mass, so results are still changing, or the results are different. And likewise, you could say the alternative and say the other ones, experiment 2, 3 and 4, the masses are the same and therefore have stopped reacting. Which statement could explain why the decomposition would not be completed? And that is the student used a spirit burner instead of a Bunsen burner. So the spirit burner may have run out of fuel, okay, or not hot enough. Whereas if we look at the other ones, the student used a high temperature. Well, that's still going to have the that's not going to stop the reaction from completing. In fact, that's going to help complete the reaction because it's a high temperature. The student used less copper carbonate. Well, that's also going to help because there's less mass there to heat, so it'll heat quicker. And the student heated the crucible without a lid on. That's not really going to have an effect, as it's still going to get the same amount of heat. Okay, so to calculate the percentage yield in her experiment, she had 3.4 grams. Okay, and she originally started with 3.7. So just like working out your score in a test, she got 3.4 out of 3.7. So the same way, I'm sure you all know how to work out your percentage in a test. That would have been 3.4 divided by 3.7 times 100 gives 92. 1 mark for the division and then 1 mark for the final answer. Question 3. So there's some artificial dyes, and this is obviously paper chromatography. Which one of the following, the food colorings A, B, C or D, is made up of only 1 dye? So you're looking for only 1 dot, and that's A. This is obviously the original dot that moved up, and it's left a trace from where you placed it. There, all of the others have multiple different colors or dyes in them. Identify the food colorings that may be contained in Sudan 1. So this should be C and D. And the reasons being that this is your safe food coloring, okay, and C and D have these ones which aren't in the safe food coloring. Okay. Question part 3. Explain how the chromatography shows that the 5 food colorings are different from each other. And quite simply, each coloring has a different mixture or combination of dyes, or different patterns of dyes, and you could have also used the word spot dye or dots instead. Okay, nothing to do with distance or solubilities. It's quite simply that this pattern here is different to this one and this one and this one. They're all different patterns. Okay, that's it for question 3. So moving on. Question 4. Sodium chloride is ionic, 1 mark, or giant ionic. Okay. And then explain why sodium chloride and sodium have different melting points. In your answer, you should refer to the types of particles and the types of forces between the particles in each substance. Okay, so sodium, I'll zoom in a bit here. So sodium has positive ions, and I'm about to give a model answer, which are held together by forces between those positive and negative ions, so electrostatic forces. So you're stating what sodium has, then you state what sodium chloride has, so that's positive and negative, and electrostatic forces of attractions. Okay, and I should say sodium's metallic, so the electrostatic forces are between the positive ions and the delocalized electron cloud. And then you make a comparison. Forces in sodium are weaker than forces in NaCl. Okay, if you started to talk about covalent or intermolecular forces or sharing, you would lose marks. Yeah, intermolecular forces have nothing to do with ion bonding. So as a model answer, I would write sodium is, actually let's change that to has. Sodium has electrostatic forces between positive ions and delocalized electron cloud. And that gets you 2 marks. NaCl has electrostatic forces between positive and negative ions. Notice the difference there. Okay, and it's got Na plus and Cl minus, and then a comparison. Metallic bonding in Na is weaker than ionic bonding in NaCl. Okay, and that will cover all your bases. So yeah, feel free to go back through that. As a little diagram to show you the difference between them, as you may remember, so Na would be positive ions. Okay, let's try to make them the same size because they're all the same, from the same type of atom. And there would be a sea of electrons. Okay, I've actually drawn too many electrons there. And so there's this attraction between the positive ions and the electrons. Yeah, these electrons. Okay, whereas NaCl has a positive ion, negative ion, positive ion, negative ion. Okay. And so the attractions between the two different ions from sodium, and so this one's sodium and this one's chlorine. Okay, whereas that's just an Na ion, and obviously that's its electron. Okay, moving on to question C. So this is a classic triple question where you've got to work out the volume of a gas. Okay, and they've been nice to you and given that value, but yeah, you have to do volume of gas questions, unlike double award. So anyway, underline as you typically do, sodium has a mass of 0.36 grams. Calculate the volume of hydrogen in centimeters cubed. So set out a table that I've originally showed you, okay, and I've put gas volume down here and a question mark next to it. Fill out what we know. Well, we've got 0.138 grams of sodium, that's from the question, okay, and the MR of sodium you just get from the periodic table. So then we can work out the moles, which I've represented as X here. Okay, and that's your first step. So moles of sodium, X, equals 0.138 grams divided by 23, and that's 0.06. That's 1 mark. Then From the equation we can see that 2 moles of sodium goes to form 1 mole of hydrogen, so we need to change our ratio, so 2 to 1. So as you can see here from this, I've divided x by 2 to get y. So moles of H2, we're going to divide it by 2. Yeah, just again that ratio, 2 sodiums to 1 hydrogen. So divide by 2, your answer from part 1. If you got this wrong, by the way, you should get error carried forward marks as long as you've divided whatever you got for step 1, divide it by 2, you should get an error carried forward mark. Anyway, if you got it right, it should be 0.003, and this is going to then go into step 3, so the volume of H2, where you now have the moles, and it tells you here that 1 mole is this big, 24,000 centimeters cubed. Now you don't have 1 mole, you've got 0.003 of it. So to find out what that volume would be, times the moles by that gas constant of 24,000 centimeters cubed, gives you your final answer of 72 centimeters cubed. Okay, so you've worked out the moles of hydrogen, and then you've times it by that gas constant. If you obviously had 1 mole, if this answer in step 2 came out as 1, then given that it says 1 mole of a gas equals 24, obviously it's going to be a volume of 24,000. But you don't have 1 mole, you've got less than that, so you times the moles by this to give you your true volume, which is 72. Moving on to the next question, part D. Mark 1 was to add nitric acid. So describe a chemical test that would show that the colourless liquid contained chloride ions. So chloride ions, this is a halide. So the halide test, we're going to add nitric acid and silver nitrate. Okay, nitric acid, this was in your previous test, removes unwanted ions. Okay, and the silver nitrate is what's going to react with that chlorine, where the nitrate is going to be displaced by the chlorine. And then the result, you'd see a white precipitate or a white solid or white suspension. You needed these two to get Mark 3. Okay, Mark 3 was dependent on Mark 2. And then finally, state one reason why this conclusion was not correct. Because she concluded that it was sodium hydroxide. Sodium hydroxide as a solid is in fact white. Okay, it's a white crystal, or it's whitish. Anyway, sodium hydroxide and hydrochloric acid wouldn't fizz to give off a gas, so that's the reason why it's not correct. If you go back to the original statement here, when she added hydrochloric acid to this compound X, it fizzed. Okay. And you should know that NaOH plus HCl goes to form NaCl plus H2O. Neither of these are a gas. Yeah, in fact they'd be dissolved in water. H2O obviously is a liquid. Okay. So neither of these are a gas, so therefore it shouldn't fizz. And given that it has fizzed, that kind of rules out it being NaOH. So that's what I put as a reason. But there were other acceptable reasons as well. Okay, thank you very much.